Hi, I'm Christian, and I'm here to talk to you about energy. What is energy? When you look at this bottle of water, is any energy in this water that we see here? Well, water consists of two atoms combined together, hydrogen and oxygen. This combination of atoms will create what you see here, H2O. Two atoms of hydrogen, one atom of oxygen fused together. You think that's energy? Well, we're going to go back and talk more about energy in atoms later on. But right now, we're going to focus on PSLE, which is coming up on Tuesday. Yes. What kind of energy questions will you get? Well, most of the time, they'll ask you about examples of bicycles going uphill and coming down, and what kind of energy do you get? Is it a potential energy when you reach the top of the hill, gravitational potential energy, and kinetic energy as you come down the hill? And what else is produced along the way? You get heat energy, of course, sound energy, if it's making a lot of noise, if you've got something scraping against the road, electrical energy, if you've got a dynamo that's linked to your tire as you cycle, and light energy, if that dynamo is linked to a lamp. So we can see that in life, you can't really get away from energy. You have it in the body, you have it in the things around you. The only thing that doesn't need energy is a non living thing. Obviously, it's quite a dumb point to say, but we're going to be looking at food. And one of the main reasons why we eat is to get energy. And with that, you look at how photosynthesis takes place with the sun. Ha ha. Therefore, we trace back to the origins of energy, which naturally comes from the sun, that gives energy through the food to humans and animals. Voila, and you're done. You have it all summed up in that one sentence. You therefore have the ability to move, work, and do all sorts of things. We're going to be looking at systems later on, but one of the other energy sources, it's wind. Apart from the sun, we have the wind. Where does the wind come from? Well, you feel the breeze as you're sitting at the beach in East Coast, and you say to yourself, wow, that's lovely, this breeze. It makes me feel cool. Hmm. Yes, it does. But what it also can do is turn a windmill and allow it to grind whatever you need to grind, like in the past where they used to use it to mill your flour. But now, most of the time, they use these windmills to generate electricity. And I was in Glasgow last year. I noticed they have some of the largest windmill uh, fields. You've got acres and acres of land, kilometers of land, just decked out with these not mills, sorry, I mean these wind vanes, which just generate electricity. The other way of generating electricity is through a hydroelectric power station. Again, you build a dam up at the top of the river and you release it, allowing large propellers to turn as you release the water that's flowing gravitationally, that's being pulled by gravity from a higher to a lower position. We don't have that in Singapore because we're mostly flat. Of course, our highest peak is in Bukit Timah, and you don't have a river flowing from there. So that doesn't work for us. We don't really have wind vanes either, but it'll be interesting to see. what comes out in the next couple of years, because we've also got biomass and geothermal energy, which comes from the ground, and wave energy, which I think will be quite interesting for Singapore, considering how we've got such wonderful seas surrounding our island. Apart from the sun, we mentioned earlier, you've got wind, you've got wave, you've got hydro. We also have non-renewable energy. And non-renewable energy includes your fossil fuels. The stuff you go into the caves and you extract ore. And this ore is used in refineries that's burned. They usually boil water, and the water produces steam, and that steam spins this turbine, which ultimately generates electricity that goes to your homes. And the electricity that we use here in Singapore is stepped down to 240 volts into your homes, and it's a 50 hertz supply. We're looking at coal. What I mentioned earlier, you've got 3 types of coal: bituminous, subbituminous, and ignite, and andesite. Well, andesite coal is one of the hardest rocks and contains more carbon, which gives it higher energy content. Ignite is the softest rock and is low in carbon content, but it's high in hydrogen and oxygen contents. The hardness and energy content in bituminous and subbituminous coal are in between andesite and ignite. Coal is the first fossil fuel to be widely used industrially and to increase people's standard of living. It is abundant, and its world's production is about 3.5 billion tons per year. That's quite a lot of coal. In China, they burn a lot of coal, especially during the winter when you rip, and most of the heaters are run on electricity. Therefore, the consumption, the requirements go high, sky high, like skyrocket. Therefore, they end up burning a lot of coal, which ends up with air pollution. I was there in 2015, and wow, it's like 400 psi. It was crazy. I tried running and I nearly died like halfway through. So anyway, I wouldn't do that again. Coming back to crude oil. So what is crude oil? How do you get crude oil? Well, crude oil or petroleum must be changed or refined into other products before it can be used. And crude oil is stored in large tanks until it is sent to various places to be used at oil refineries. And the thick black crude oil is split into various types of products by heating it. So the gas that you call it petrol in the petrol stations in Singapore, in the US they call it gas because it's actually gasoline. So yeah, that is used by refining. And Singapore's got quite a good industry. I mean, you've got Shell, ExxonMobil. If you go to Jurong Island, you see all these refineries there. And they're really strict if you drive into Jurong Island, by the way. You're not allowed to smoke. Very, very strict designated areas only. It's a refinery, so there's lots of this gas flowing around. Again, petrol, naphtha, kerosene, diesel oil, fuel oil, and bitumen. These are some of the products that come from crude oil. And I have to say that your aeroplanes are fueled with Jet A1 fuel. It's kind of like kerosene, and so it's really low grade if you compare it to petroleum, for example. How petroleum gas. And what's interesting is it's the refinery cools the gas and you get bottled gas, and that's the ones that's used in your homes to cook your LPG, liquefied petroleum gas. that's used to cook, and that's right at the top of the refinery. So again, where do you get your heated crude? Where do you get your crude oil in the first place? Well, of course, you get it from your bedrock. It's you've got all these drilling companies that go out into the sea, and they drill deep into the core to extract crude oil. It's really black, and you don't even want to look at it. But yeah, crude oil is made into many different products and fertilizers for farms, clothes that you wear, toothbrushes that you use, things like that. And there are also materials that, like your milk bottles, for example. It's interesting, isn't it? So most plastics come originally from crude oil. I don't know if you knew that, but yeah. Natural gas. Let's move on to natural gas. Lighter than air. Natural gas is lighter than air. It's also made up of a gas called methane. Methane is made up of carbon and hydrogen atoms. This is highly flammable. You don't want to be stuck in a room with methane gas. It's like, yeah, you strike a flicker and you're dead. Like it would totally explode. Okay. Natural gas is widely used alongside coal and oil and is a very versatile fuel. I'm sure you've used natural gas. Just go to your stove right now and try and boil an egg or something. Boil water to cook an egg. It was initially seen in the same way as crude oil, and in the 1970s, it was increased in exploration. And I can say this, in countries like Azerbaijan, for example, you would be walking down the street and be looking at flames coming from the ground. They're on tectonic plates, which just off the Caspian Sea, which just naturally have a lot of natural gas coming from the ground. Hence, the country is booming ever since the oil prices went sky high. It's come down, it's tapered down a little bit, and therefore they are experiencing a little bit of a slowdown. But nevertheless, prices of oil is still stable because, as you know, everybody needs electricity today. Not so 200 years ago, not even 100 years ago. Not too long ago, we were all using oil lamps. And hence, many people's eyesight were very bad because if you notice, you try reading with a orange light, your eyes will start getting very blurry after a while. And hence, it was always advisable to read during the day. And once it wasn't dark, like 7, you would rest and then try and wake up at 5 to catch the sun. But today we have light from bulbs and fluorescent tubes and LED lights too. So that helps. And food. We're going to go on to the food chain, and also in line with our energy team. As we were talking earlier, you've got the whole flow in the food chain. And like we said earlier, we looked at carbohydrates. That's the stuff that's stored in the plant cell, like little packets of molecules that stored energy. So there's carbohydrates. And some of the most important and simple types of carbohydrates are called sugars. And one of the most important sugars for animals and humans is glucose. Plants capture the sun's energy and use it to convert carbon dioxide. You know, the stuff that we don't like, carbon dioxide, like it's 0.03% of like air. That's the stuff we don't want. But yeah, the plants want it. And the plants cover like half of the globe, except in Singapore. But yeah, generally in the world, it's more than half, I think. I think waters cover 70% of the world. Okay, the process is called photosynthesis, as you know, and it begins the chain of energy conversions. And you know what? I have a little planted tank which I just set up, and you can see the photosynthesis take place throughout the day if you want. You just have to hack the system and leave the lights on 24/7, and you just produce photosynthesis. It'll just like produce oxygen throughout, like non-stop. But then I asked a friend who does this for a living, and he sells like vegetables and stuff, organic vegetables. And I said, so what happens if you just don't let the plants respire? What happens to the plant? Will it taste the same? And his answer was, it's ethically not so good. Yeah. So it's kind of like, yeah. Anyway, the plants in return are eaten by animals, you and me, as well as the rabbits and terrapins, and then they transfer the energy in organic compound from one animal to another. And some examples are lion eating a deer, for example, blah blah blah. You know all that stuff. Although we don't have lions in Singapore, no. We've got wild boars though. The wild boars don't eat. No, wait, do wild boars eat rabbits? No, I've not seen wild boars eat. But they do eat meat though, because pigs eat. Like they're omnivores, like they eat anything. Yeah, okay. Coming back to energy, bacteria and fungi are referred to as decomposers. Did you know that? They feed on dead living plants and animals, breaking them down to simpler nutrients. And with the simpler nutrients returned back to soil and then can be used by the plants, and the energy transformation starts all over again. Okay, now, do biological processes rely upon the supply of energy? Yes, both plants and energy are absolutely dependent upon energy for growth and movement and the maintenance of basic function and structure. Solar energy, yay! We're doing a lot of solar today in Singapore, don't you know? Like all our HDB flats are going to be lined with solar panels, finally. It's taken us long enough. Well, they're called photovoltaic, or PV for short, energy. And this is a simple and earth-friendly way to get energy because it will produce small amounts of voltage, which can be used to power up lights and energy machines that don't use that much energy. Unfortunately, motors take a lot of energy. And therefore, if you turn on your vacuum cleaner, be sure to use it quickly because your vacuum cleaner takes up a lot of energy, like 700 watts at least. How much is 700 watts? Try looking at the number next to the vacuum and it'll tell you like how many watts it contains. Like it takes up. That's the amount of energy it uses. So it's like a big guy like Arnold Schwarzenegger, for example. If he were to run around, he'll use a lot more energy than you or me because we're smaller and we use less energy. We take up less carbohydrates. Okay, now we're going to look at the disadvantages of using electricity that's generated by solar power. It's that the sun rays are scattered and too irregular. And solar power is interrupted by night and cloud. And, if there's haze, it's not going to work. And therefore, it's a free source, but it's not available all the time. And it also, well, it's expensive. Let's face it. Putting up a bunch of panels in a roof, not only do you have to maintain it, you've got to make sure you've got all the gunk swept off the top each time. And because it's on the roof, it's sometimes very dangerous. So it's stuff like that. And that's one of the reasons why it hasn't been so heavily adopted in countries that have access to energy. Like to fossil fuels like we do, because it's still cheaper to burn, but it's not very good for the environment. Sorry. Forms of energy. We're going to be moving on to kinetic and potential energy. I'm going to be discussing how that translates. That's actually really simple. And I think you all know that. But something that makes it a little bit more exciting is that on top of potential energy, you can have gravitational potential energy. So stuff that is on the top of the hill, waiting to come down, that object has gravitational potential energy. Yes. Okay. GPE for short. Elastic potential energy is the other one. If you pull a band waiting for it to pop back, that's got elastic potential energy. And chemical potential energy is you and me after having a really hearty dinner. You've got loads of chemical potential energy to do your handstands, your jumping jacks, whatever you want to do. And I need a bit of H2O. Just to recap, what's the boiling point of water? Yes, did I hear 100? You are absolutely right. It's 100 degrees Celsius or Fahrenheit. What did you say? Celsius? Yes, you're absolutely right. You're really smart. Okay, what's the difference in Celsius and Fahrenheit? That's a topic for another session, which we'll go deep into, because you also got Mr. Kelvin on top of Fahrenheit and Celsius. But for now, we're just going to be talking about Celsius, because that's the one that we use in Singapore based on the metric system. What is the metric system? It is what differentiates meters versus feet and pounds versus kilograms. Another topic, good for you to know. Google it if you can't wait. But now we're going to be focusing on chemical energy, which is, again, your foods, your batteries, and your biomass and petroleum, natural gas, and propane. These are all examples of chemical potential energy. So don't forget that during exams, okay? Batteries, potential, chemical potential. Remember that. Electrical energy. It's the movement of electrical charges, and everything that's made up of tiny particles are called atoms. I said that earlier. Atoms are made of even smaller particles called electrons. Aha! And protons and neutrons. And if a force is applied, it can move some of the electrons. And when these electrons move through a wire, it is called electricity. Presto. Lightning is another example of electrical energy. Have any of you all experienced being electrocuted by lightning? Silly question. None. You won't be here listening to me if you did. Yes, because you're looking at like a couple of thousand volts of electricity passing through your body, which is, it's not the volts that kills you, it's the amps. Amps is the power. Yes. So that's totally outrageous to think of it. Heat energy. Heat energy is thermal energy, and it's the energy it is the internal energy in objects and the vibration and movement of the atoms and molecules within a substance that produces heat energy. Good question is geothermal energy. What's that? What's geothermal energy? I had a problem understanding geothermal energy for a long time. How could you harness heat from the ground? I'm like, if I lie on the ground, it's usually cool. How is it hot? It doesn't make sense. But if you think about it, at night, if you go to the seaside, it's usually warm breeze that blows across. And that's the heat that comes up from the ground and goes up and gets blown across. So a geothermal power plant uses the magma. As you know, the earth core is filled with magma, which is really hot. And that travels upwards. And they use an injection well to extract some of that heat, power up your plants. Not so much of focus on that now. Gravitational energy, again, it's the position of place. A rock resting on top of a hill contains gravitational potential energy. A hydropower, for example, has water in a reservoir behind a dam, and the minute you release dam, the water flows through, and you therefore have potential gravitational energy translating into what? What's that? That's kinetic energy. Motion energy, kinetic energy, same thing. It's commonly known as kinetic energy, and it's the energy possessed by an object due to the movement from one place to another. Wind is an example of motion energy. How many of you all have sat in a sailboat before? Do you need a propeller? Not really. You need a rudder, or else you'd be like going all over the place. Elastic energy. It's stretched or compressed objects. Compressed springs, for example, and stretched rubber bands are examples of objects having elastic potential energy. Have you ever been hit by a rubber band? It's painful. I know. Somebody did that to me recently. I got really upset. They were like, oh no, not my face. Okay, sound energy. How you are listening to me right now is an example of sound energy. And it's the substance, it's the movement of energy through substance in longitudinal waves. Yeah, that's right, waves. Okay, sound is produced when a force causes an object or substance to vibrate. The energy is transferred through the substance in a wave. You've got a voice box right here, and that is vibrating, and therefore the sounds are coming out. You've got radiant energy. Radiant energy is sometimes called light energy, and it includes infrared or ultraviolet radiation. Okay, nuclear energy is the last one we're going to talk about, and that's part of your potential energy because nuclear energy, it's stored. How you get nuclear energy? You know what happened in 2008 in Japan? Yes, there was a huge tsunami. It blasted through the protection walls, and it like totally damaged the nuclear plant, and there were many people who died. And on top of that, there was a huge bad nuclear leak. Yes, it was terrible. So what happens in a nuclear reactor? Haha. I'm going to give you a little bit of insight. Are you ready? Yes. The energy can be released when the nuclei are combined or split apart. Nuclear power plants split the nuclei of uranium atoms. Uranium, yes, the stuff you talk about with Superman and all of that. Marvel comics, uranium, And in a process called fission, Fission, beautiful, fission. Okay, the sun combines the nuclei of hydrogen atoms in a process called fission, Fusion, fission and fusion. Okay, scientists are working on creating fusion energy on Earth so that someday there might be fusion power plants, which would be much safer. But right now, it's all about fission, Fission. And we don't have a fission, we don't have a nuclear plant in Singapore because of the small radius and distance we have from people living in particular areas, and therefore, if there was a leak, it'd be quite dangerous, and everybody would just like become mutants and get cancers and stuff. Because in Russia, that's what happened in the Chernobyl disaster a couple of years ago, and we all remember that. And many of the babies who were born were all deformed. Sad, yes. So, what is gravitational potential energy? It is energy that is possessed by an object due to its vertical position above the ground. Okay, gravitational potential energy. Remember that. It's like a swinging ball which is hung on a crane, and then it's like it's got gravitational potential. Because if you drop that ball, it'll fall down and smash something. There you go. So the energy increases as height increases. Mm. So a good question was, somebody asked me that, what happens if you were to take a pin and drop it from a 50-story building? Would it be powerful enough to pierce through somebody's skull? What do you think? Anybody? Well, the reality is that there is a threshold, and after that threshold, the power stops building up. It's usually about 10 stories or so. More massive objects have greater gravitational potential energy. So, like I mentioned to you about the pin, you've got very, very little mass in that pin in the first place. So, yeah, not really able to add up to become a fighting force to kill people. Your pin dropping from the 50th story. Anyway, the big boulder, on the other hand, that weighs about 100 kg, or maybe 200 kg, or maybe 500 kg, would be potentially very dangerous if it's rolled down a hill, and that would cause a lot of damage, like serious damages. It goes down, and people just get bulldozed over and stuff like that. And that's what usually happens when you have massive avalanches, where you see these balls of snow rolling down the mountain, and people below just start like screaming, I'm gonna die, and like, oh, then they get caught up in this ball that rolls and like smashes everything in its sight. It's the snow. What are you talking about? No, not snow. Because snow with gravitational potential is a major force to be reckoned with. Okay, so what is kinetic energy? Kinetic energy is the energy of motion. No, there's no kinetic energy in that. No, it's the energy of motion. Motion. And the amount of kinetic energy which an object has depends upon two variables. First, the mass of the object and the speed. Two things, very important. The higher the speed of an object that's moving, the more kinetic energy, right? Right? Yes. It's just like a bus traveling down Nicole Highway at 70 kilometers per hour. By the way, a bus shouldn't be traveling at 70 kilometers per hour because it's above the speed limit. Buses should go at 60. And why do buses have 60 speed limit and cars have 70? Well, again, it's because the bus has a bigger mass. And if a bus were to smash you at 70, it would be scary. Okay, but the car, on the other hand, which is smaller, probably won't do as much damage. That's the reason why cars have generally higher speed limits than large vehicles like buses and lorries and what have you, cement mixers, and the list goes on. You know what I'm talking about. Wonderful. What is light energy? Okay, electromagnetic radiation, EM for short. This kind of radiation is not harmful except for the occasional sunburn. All of you who like East Coast or Sentosa tanning, yes, sunburn. There are other kinds of electromagnetic radiation like radio waves, microwaves, X-rays, but light is the only part we can. Yes, light is everywhere in our world, and we need light to see what is around us as well as to see colors. Do you have anybody you know that is colorblind? I do. And when I asked him, so how do you drive? Well, he says he recognizes the lights in the direction. And hence, do you notice why red is always on top, amber is always in the middle, and green is always at the bottom? It's to help people who are colorblind. Ding, ding, ding. Yes, that is the reason why traffic lights are always the same everywhere in the world. You always see them vertical. Well, there are some overhead ones that go this way. But yes, that's like supplementary. You will never see an overhead traffic light without a vertical traffic light, period. Now, coming back to light, we are able to see colors and shapes of different objects because of light that bounces off the object. Remember, the object, unless it's a traffic light that emits light out, everything else, objects basically don't emit the light. It's the reflection from the source, whether it's a bulb or the sun, that reflects and bounces back to your eye. That's a pointer for you in your little exam where you have to draw your lines, I guess. Just remember that. We're able to see them, and our brain processes it, and the light is an essential part of the process. For example, we're able to read when the lights are dim because our pupils start to dilate even more. Like the pupils get bigger, And you see it in cats, especially. You can see it really well in cats and how their pupils dilate. Again, besides enabling us to see objects, light also enables plants to make food. I think that's very important. Like we mentioned earlier, photosynthesis. And like always remember this. If there's one thing you must remember, light always travels in a straight line. Does light go curvy-wurvy? No. Okay. Why? Because the straight paths of light are called light rays. Simple as that. And light travels at a speed of, what did you say? 300,000? Yes, you're right. 300,000 kilometers per hour. Did you say second? Really? Kilometer per second? Like one. And the guy like, phew. Yes, you're right. 300,000 kilometers per second. That's how fast light travels. And which means that the light from the sun takes only about 8 minutes. 8 minutes to travel 149 million, I say again, 149 million kilometers down to Earth. Yes, that's how far the sun is from us. But look at how fast it reaches us. Incredible speed, isn't it? We wish we could run at that speed. That'd be nice. So what is heat energy? Now, I like heat. I love heat. This is what keeps me alive. It's heat. Heat is energy that's being transferred via a medium from hotter to a colder region. And heat can change the matter it touches. For example, with water, when it touches the hot pot, this temperature increases, and it can cause the particles in it to vibrate and cause a chemical reaction like burning to take place in matter. So heat is also released when there is friction. Do you do that when you're in a cold country? I do. And it can produce chemical reactions such as the nuclear reaction, like what we talked about, the fission that makes the sun burn. The sun burn, that's also a nuclear reaction. So heat is often released along with other kinds of energy such as light and sound. And a burning candle. I don't have a candle with me. Whose birthday is it? My finger can't light up, unfortunately. No, this work. Yes, it releases light and heat, and an explosion releases light, heat, and sound. Like when you set off the atomic bomb, which unfortunately hit Nagasaki and Hiroshima in 1945 during the World War, and that was what ended the World War, and Singapore was, released from Japanese occupation. Some of you know the history, some don't. You'll find out next year when you study history, for sure. And like heat can dry your clothes, cook, you can do many things. You can iron. And you probably ask some of these questions, I believe. What can heat be used for? It is a form of energy that can be transmitted with or without a medium and can be used to cook, dry things, and keep warm. Sound energy. Sound is a form of energy, and it is a wave which is created by vibrating objects and passing through a medium from one location to another. And a wave is passed on of energy by a series of vibrations. And there you go. All matter are made up of particles, like I talked to you about earlier. The only difference is how loose or how tightly knitted they are. Like a solid item has got their particles all tightly knit, and that's why I can't squeeze this bottle. Because it's got all its particles tightly knit. But when they're loosely knit, that's when you can do whatever you want with it, like gas. Yes. Okay. When energy strikes the molecules of matter, it causes the molecules to vibrate back and forth, producing a wave that transmits sound energy. And since molecules in a solid do not move very far and bounce back very quickly, a solid is an excellent transmitter. I say again, a solid is an excellent transmitter of sound. Yes. Did you hear that? It was my bottle. Yes. Okay. So, but liquids, on the other hand, do not transmit sound very well. You can hear this. Oh, not yet. I'm gonna gargle. That wasn't very loud, was it? That was because it was just liquid compared to. Okay, but gases, on the other hand, are the poorest transmitters of sound. And sound travels quickly at air at nearly 344 meters per second, but travels through steel at about 5,100 meters per second. It's a lot faster, isn't it? And therefore, if you pass sound through a steel object, you will be able to hear it a lot quicker than to pass it through air. Like when you shout or you use a pipe and you put it to your friend's ears, you don't even need to shout. Think about it. So each time, even at high speed, sound travels a lot slower than light. Recall the last time you experienced thunder and lightning. What comes first? Yes, lightning. You're right. And you can there's an interesting telltale sign about how soon the storm is going to come. It's when the gap between the lightning and the thunder gets shorter and shorter. When the storm's going to come, because when you hear the thunder, that's when the clouds are like arriving, because as you know, thunder comes from the clouds. Did you know? Sure you did. Well, I'll explain in another lesson about thunder and lightning. The temperature at the medium can also affect the speed of sound. As the temperature of a medium increases, the speed of the sound also increases. Did you understand what I just said? The temperature and the speed of the sound is linked. Yes, it's linked. The higher the temperature, the faster the sound. And that's one of the reasons why singers always like to keep their voices, or they would like have a warm drink before they go up on stage and sing. Because, yes, you want to keep it warm. So it allows more beautiful sounds to be transmitted. Now, moving on to my favorite part of energy, electrical energy. Yes, electricity is one of the forms that we use every single day through our phones and through our iPads and even the laptop that I'm using right now to record this. It can be created by burning fossil fuels, which I talked about earlier, or by renewable energy, water, wind, sun, or biomass. And when energy is generated from fuel sources, it's usually made at large power plants and creates pollution. Like what we talked about, the coal plant in Beijing that caused all the haze and everything, which didn't allow me to run, and I was really upset. Yes. But not so much about me, but more like because of the babies that were like crying and stuff. Anyway, so electricity from renewable sources are usually made on a small scale and does not pollute. I thank you very much for listening to my topic on energy. And if you have any questions at all, feel free to ask me. But just as an end note, I want to ask all of y'all a quick question. What happens when you drop a ball? Did you say gravitational potential energy? Converting to gravitational potential energy plus kinetic energy and down to kinetic energy? Yes, kinetic plus heat plus sound energy. Because when the ball hits the ground, it produces heat. Anything that strikes produces heat, like it or not. Yes, even if you try and punch my face more times, you feel your hand getting warm. And yes, it always applies. Wonderful. I hope you enjoyed this lesson. Just to recap, food is stored energy. It is stored as chemical potential energy, and when your body uses that stored energy to do work, it becomes kinetic energy. First point. Second point, we've got 7 to remember. If you overeat, the energy in food is not burnt, but is stored as potential energy in your body. 3, when you talk over the phone, your voice is transformed into electrical energy. Which passes over wires, and the phone on the other end changes the electrical energy into what? What did you say? Sound? Hey, you're absolutely right. Sound energy through the speaker. Perfect. Number 4, the car uses stored chemical energy into petrol to move. Yes. The petrol station where you pump fuel. Yes. The energy changes the chemical energy. The engine changes the chemical energy into heat and kinetic energy to power the car. Number 5, the toaster. The toaster that toasts your bread in the morning, if you have a toaster. Well, it changes electrical energy into heat and light energy. And if you look into the toaster, you will be able to see the glowing wires, which is very hot. Don't put your finger in it. Number 6, the television. It changes electrical energy into light and what? Sound? Thank you. Number 7, last but not least, An electrical fan changes electrical energy into kinetic energy. With that, I thank you all. Do like me, put your links on the video and share comments. All the best. My name is Christian. Bye.